Hi everybody. As you may have noticed, the booklet is called Sequences and Series. We've had a bit of a look at what sequences are, and so now we're moving on to what is a series. The first thing we need is a little reminder that a sequence is an ordered list of numbers defined by a rule. And moving on from that, a series is simply the sum of a sequence. So we add them all up. So add up T1 plus T2 plus T3, however many terms you're adding up, and that is the series, the sum of them. There's two different options. The first one is a finite series, and that's largely what we'll be working with. And a finite series is the sum of a finite number of terms. So for example, S20 means the sum of the first 20 terms of a sequence. Okay, so S20 would be the first term, T1, plus the second term, T2, plus the third term, T3, plus all of the terms in between, and then our last term is T20. Generally speaking, Sn, which is the sum of n terms, is going to be term 1 plus term 2 plus term 3 plus all the terms in between up to our nth term, whatever we decide n to be. And one of the reasons that we'll be working with finite series rather than infinite series is that the sum of a finite series is always a finite real number, which basically means it's one of the numbers that we're used to dealing with. On the other hand, an infinite series is the sum of an infinite number of terms. So the way that that's written is sum to infinity, term 1 plus term 2 plus all the terms in between, plus term n, which is just any given term, plus every term that comes after that all the way to the theoretical term infinity. And there are ways of calculating that, but it does get quite a bit more complicated. Usually the sum to infinity equals infinity. So it actually becomes a little bit pointless in lots of cases, that if you just keep adding a sequence of numbers, if you keep adding more numbers, often you will just keep adding numbers until you get to infinity. So not super helpful in that case. Sometimes, however, a series will do what's called converge. And converge means it will add up to a finite real number, as in it will add up to just a regular number. But like I said, we're not doing infinite series. If you're interested, an extension question for you to consider, and I do mean extension, I'm never going to ask you this in a test. The question would be, under what circumstances would an infinite series converge to a finite number? So have a think about what sorts of numbers you would have to be adding up to end up at something other than infinity. But like I said, for the moment, we're just dealing with finite series. And in the first little example, we'll go through some very simple finite series.